Now we're going to look at a different aspect of our API projects. If you noticed, the orders API is in a single file and it got really long, so it's getting harder and harder the more features we add to manage all the application in a single file. So what we are going to do now is to split this application into a nice file structure that includes multiple modules and packages. So here in my slide you can see the application structure that we are going to implement. You can see that at the top we have our orders directory. This is the same as before, but now instead of having a single file in this folder, we are going to have 3 top-level folders: app, which is the application package; config, which stores configuration files; and tests, which stores unit tests. Then in the top level folder we are going to have a runner script. This is run.py. We are going to use this to run the API. And we have test, which is going to be the runner for the tests. The application package is going to have all the application functionality, but now it's going to be distributed in several packages and modules. So you can see at the application folder level that we have a sub-package called API v1. This is a topic that we haven't covered before. When you develop an API and you want to be prepared for changes that you may need to do in the future, it's a good idea to give the API a version. Now, this version does not need to change every time you release a new product out. It only needs to change when you need to introduce backwards incompatible changes. So API v1 could be very well an API that lasts for several major versions of your project. But once you need to change something in a way that will break clients that expect to use the older API, then you can leave API v1 for those older clients and then add another package here that's going to be API v2. And there you implement the new API. Then for some time you can keep both running. Eventually you will deprecate your v1 API, and then in time you will remove it from your project. But this way you can make upgrades and not break clients that are expecting the old API. So my API v1 package has the routes that I implemented for customers, products, orders, and items. And note that instead of having all in a single file, now I created a different module per resource. So as the API grows, I will continue to add modules in this package. If you look back into the app package level, we have auth. This is where I put all the authentication related routes and auxiliary functions. This is where we have our verify password functions and all the dealings with tokens and usernames and passwords. Errors is where I have my error handlers. I have my exceptions also separated into their own module. Models is where I have my database models. But here I'm a little bit torn. It depends on the size of your database. If you have a small database, it's fine to have all the models in one file. If the database grows, I will probably create a sub-package here and I will call it models, same name, but then inside it I will store each database model in a separate file. And here I have in my utils.py module, I have any auxiliary functions that I need. And if you remember from the early sections in this class, this is where I stored my split URL function. This is the function that provided the ability to reverse a URL into its components. So far, when we run the API, there was no specific configuration. If we needed to configure anything, such as the database URL or the secret key, we just went and set the key in the app.config dictionary. That is really not a good way to work with a project that grows, because when you have different modes in which the application runs, it's hard to control the settings when they're different. Here I'm having a much more flexible model in which I have different settings for development, testing, and production. So here I have configuration variables that I can use and make them be different depending on the mode. And one thing that I do here is to have different databases for these modes, because I never want those to use the same database and mix data among them. As I need to add new configurations, I can always add more here. If I need to deploy this to a cloud service, for example, I can add a production-specific configuration for that cloud service. And if I need to deploy to a server that's dedicated, I can also add that. My tests directory contains my unit tests. And here I can separate the tests and group them by resource that they work on, or any other way that I see necessary so that the files don't grow too big. So we are going to check out version 0.10. And now we have our orders directory transformed into the structure that I just described. So let's take a look at a few of them. We're not going to look at all of them. Most of them are just copies of the proper sections in the previous version, but let's see how the configuration is done. So this is a Python module. So here I can run code and do whatever is necessary to come up with the values for my configuration variables. Note that in previous versions we used to run our application by passing debug equals true at the bottom of the script in the app.run call. Now, since I have independent configuration files, I can set the debug mode directly in the development configuration. Another thing that is complicated when you're working in development is having to provide authentication, and here I added a support for ignoring authentication in debug mode. My database, as I mentioned before, is now separate from the other modes. So here I decided to go with a new name. This is called data-dev. For testing, I'm going to use data-test. And for production, it's going to be data.SQLite. This is the runner script. This is what I use to run the application. So here there are a few changes. In previous versions, we created the application as a global variable. You remember that we said app equals Flask, and then we passed name as an argument. So that was a global variable that enabled us to use app.route and any other decorators. Unfortunately, that is not a very good way to structure a larger application. Many times you find that to configure the application, you have to apply logic. Right now, we have 3 different configurations, and we will need to select the one to apply. So this is hard if we create the application as a global variable, and we don't have a way to evaluate logic to decide what configuration to use. So instead, I changed this, and now I have a function that makes an application. So this function is in the package that has the application, in the app package. And I can invoke it by calling create app and then passing the configuration that I want to use. So here you can see that I can set the configuration by looking at the environment. So if I have an environment variable called Flask config, I'm going to use that as my configuration. If I don't have that, the default is going to be development as before. Since I have the application created dynamically, now I need to create an application context before I can use my database. Flask SQL Alchemy will not know what database to use or where to go get the database URL if it doesn't have an application associated with it. When you create the application dynamically, the way to do that is to create an app context and activate it. So I did that for this block, and that is how I can call my create_all function, and then I can create a basic development user that I can use to authenticate. And this is just a time saver, so that I don't have to create a user when I work in development. This makes a default user John with password cat, and if I need to use it, I know it's always there when I'm running in development. And finally, I'm calling run, and this time I don't need to provide the debug argument because that comes from the configuration. So to end this, let's take a look at the create app function. So that is in my app package constructor. And here you can see I initialize my extension, Flask SQL Alchemy. I used to pass the application instance here. Now I don't have an application instance, so I'm going to use the alternative way to initialize an extension, which is to create the object with no arguments, and then when you have an application, you call init app on the extension, passing that new application that you have. The create app function creates the Flask instance and then applies the selected configuration that comes as an argument. For this, I'm using a special method from the config object in Flask. I'm telling it to go grab configuration variables from a Python file, and I pass the path for my selected configuration in the config directory. So that will bring all the configuration variables. This will associate the database extension with my application. Recall that we had the routes in a blueprint. That blueprint was all in the same single file, but now we moved it to the API v1 sub-package. So now I'm importing that blueprint from there, and then I register it the way as I did before. This additional argument that I'm using adds a prefix. And I decided, now that I grew and I have a more professional application, I want to show and include the version number in the URLs. So whenever I register a blueprint, I can add a URL prefix, and this will be prepended to all my routes. So now, instead of saying localhost 5000/customers/, I'm going to have to say localhost 5000/API/v1/customers/. And that will enable me to create a v2 eventually if I need to. I mentioned that we moved the authentication features to its own module. So now I need to import that and create my authentication token route. So here you have that same route, but now I'm importing the auth object, which is the Flask HTTP auth extension object, so that I can create that route and add it to the application. And finally, I return the application to the caller so that the runner can call app.run. So this is the new structure. Just to make sure that this is very clear, I'm going to do a quick test. I'm going to run the application. Now it's running. I'm going to open a new window. And now I'm going to say auth. I'm running in debug mode, so I know for sure I have John Cat inserted for me. Cat, I'm going to call localhost 5000 get auth token. This will give me my token, and now I can use the token to send an API call. And this is the one that I want to show you to make sure that you understand. I'm sending the token and an empty password, and this is get localhost 5000 API v1 customers. And now, since I have a new database, this is empty. But you can see here that now all the URLs are going to have the API v1 prefix. I'm going to stop this, make sure the tests are running fine using my new test runner. Test.py, run the tests. It runs coverage. Now the report is much nicer because we have everything separated into different packages and modules. And here we can see that we are currently covered at 82% with my tests. And we have a very good indication of what's missing. So you could write more tests based on this report.